Today we are going to talk about the multiplication principle. It says that assume that a task T can be decomposed into R ordered subtasks T1, T2 up to TR. You can see here. There are n1 ways to do the subtask T1 and n2 ways to do the subtask T2. And there are n-r ways to do subtask tr. Then the total number of ways to do the whole task t is given by the product of all these tasks. You can see this is the product of n1, n2 up to nr. What is n1? n1 is the number of ways to do the subtask t1. What is n2? n2 is the number of ways to do subtask t2. nr is the number of ways to do subtask tr. So the difference between these two rules is that in the sum rule of counting or addition principle, the task was not divided into subtasks. In that rule, we had either n1 ways to do the whole task or we had n2 ways to do the whole task. And then we use the sum rule of counting. But in this case, our task has been divided into subtasks T1, T2 up to TR. N1 is the number of ways to do the task subtask T1. N2 is the number of ways to do subtask T2. Similarly, nr is the number of ways to do subtask tr. Then product rule of counting says that the number of ways to do the whole task is product of all these number of ways. So let's do an example. So this example says to reach city D from A, one has to pass through city B and then C. If there are two ways to travel from A to B, 5 ways to travel from B to C, and 3 ways to travel from C to D, then find the total number of ways from A to D. Look at the solution of this example. First we make the diagram of this situation. Let us have city A here. This is city A. B here. C here. City D here. He says that there are 2 ways to travel from A to B. So from A to B, I have this way and this way. So I have these 2 ways from A to B. Then he says there are 5 ways to travel from B to C. So I'm going to make 5 different ways from B to C. This is way number 1. This is way number 2. This is way number 3. This is way number 4. And this is way number 5. So there are 5 ways from B to C. And then he says there are 3 number of ways from C to D. So from C to D, we have 3 number of ways. Let's say the first one is this, second one is this, and third one is this. So this is the picture of traveling from city A to D. Then the total number of ways from A to D can be found by multiplication principle. So in order to find the total number of ways from A to D, we have to use the product rule of counting or multiplication principle. Because in this case, your task is to go from A to D, where it has three subtasks. In the subtask T1, we will go from A to B. In the subtask T2, we will move from B to C. And in the subtask T3, we will go from C to D. Since the number of ways to do task T1 means the number of ways to move from A to B. Since number of ways to move from A to B are 2, you can see here. So I will write here 2. And the number of ways to do task T2 are 5 because it was given in the question that there are 5 ways to move from B to C. And here T2 means to go from B to C. Therefore, the number of ways to do subtask T2 is equal to 5. The number of ways to do task T3 are 3. So in order to find the number of ways to do the whole task T can be found by using product rule of counting or multiplication principle. So the number of ways to do the whole task means to go from A to D is the same as the product of N1, N2, N3 because N1 is the number of ways to do subtask T1 which is 2. So I will write here 2 and 2 is 5, you can see here. I will write here 5 and 3 is 3. So the product of these three numbers is 30. Now look at the product rule of counting in some different way. Let the finite product I from 1 to R AI denotes the finite product of A1, A2 up to AR. It means that this finite product is the same as A1 cross A2 cross up to so on cross AR. Then the product rule of counting or multiplication principle says that the cardinality of the product is the same as the product of their cardinalities. So this is the whole set theoretic definition of product rule of counting or multiplication principle. So in order to understand precisely the concept of the product rule of counting in set theoretic way, let's have another example. So in this example, we have to find the positive divisors of 600, including 1 and 600 itself. In order to find the positive divisors of 600, we first have to factorize 600. You know 600 can be factored in this way: 2 to the 3 times 3 to the 1 times 5 to the 2. Okay, since every divisor of 600 is of the form 2 to the power a times 3 to the power b times 5 to the power c, where a can be 0, 1, 2 or 3. Similarly, b can be 0 or 1. C can be 0, 1 or 2 because Maximum power of 2 is 3 here. Maximum power of 3 is 1 here. Maximum power of 5 is 2 here. Since every divisor of 600 has 3 subparts, first one is 2 to the A, second subtask is 3 to the B, third subtask is 5 to the C. Since for A we have 4 possibilities because A can be 0, 1, 2 or 3. B can be 0 or 1. C can be 0, 1 or 2. So in this task, you can see A has 4 number of ways, B has 2 number of ways, and C has 3 number of ways. So by the product rule of counting or by multiplication principle, the total number of divisors of 600 is given by 4 times 2 times 3, which is 24. So this concept can be generalized. If you have a number n whose prime factorization is p1 to the alpha 1, p2 to the alpha 2, up to so on pr to the alpha r, then the total number of divisor for that n is the same as we have done in the previous example. So what we have done in the previous example, because 600 was the product of 2 to the 3, 3 to the 1, 5 to the 2, you can see what is 3 plus 1, which is 4, what is 1 plus 1, this is 2, what is 2 plus 1, that is 3. So we have only multiplied powers of primes increased by 1. So we have taken the product of powers of primes increased by 1. So in this case, we will do the same thing. What is the 1 increased power of alpha 1? That is alpha 1 plus 1. What is 1 increased power by alpha 2? That is alpha 2 plus 1 dot dot dot. What is 1 increased power by alpha r? That is alpha r plus 1. So it is the general formula to find the divisor of any integer n. And this is only because of multiplication principle or the product rule of counting.